Lately, I've been completely enamored with this paper I've been studying over and over, two papers about this new concept of what causes cancer and therefore how to deal with it. So this still has to be checked out. But what I really love about this idea of what causes cancer and therefore what we need to do about it is the simplicity of it. It is so elegantly explained by these authors. So I already did an intro video on this topic. In today's video, I'll talk about the 10 interventions they listed. And I mentioned them in a previous video. In today's video, I'll talk about why they specifically focus on those 10 interventions. And they included 3 natural substances or micronutrients, 3 drugs or medications that are already approved, and 4, let's say, lifestyle changes. Okay, and the purpose of what you want to achieve with any of these, and by the way, this approach that they claim is good for any cancer, because what their idea of what causes cancer, and I'll get into detail of it a little bit, is that it's universal for all cancers. So there's 3 things you're aiming to achieve here. Number 1, you want to remove access of glucose and glutamate to cancer cells, because that becomes the primary food source for cancers because of the nature of what's happening inside cancer cells, okay? So that's the target we want to achieve, number 1. Number 2, you want to restore mitochondria function. So what are mitochondria? Mitochondria are tiny little organelles inside our cells. So just like our body has organs, our cells have also organs called organelles. Mitochondria is super important because they basically produce energy batteries for everything we do. Basically, they produce energy for us to be alive. And they do this via a process called oxidative phosphorylation. And the name is not important. Oxidative is because you need oxygen that we breathe in the process, which basically what the oxygen will do, will take an electron. There's like a movement of electrons in this process that helps mitochondria build these energy batteries called ATP molecules. And this process is very versatile. It can use sugars, it can use fats, and you can use proteins as food source. So it's extremely versatile. Now this process is completely broken inside cancer cells. And as a consequence, normally what needs to happen is sugars, for example, if the sugar is the main source, sugars would be broken down into couple molecules called pyruvate. Again, the name is not that important, but then that pyruvate molecule can enter mitochondria and oxidative phosphorylation can commence, right? Because mitochondria oxidative phosphorylation is broken in cancer cells, they need just glucose breakdown inside the cell. It does not use mitochondria, so it needs and that glucose breakdown itself produces a little bit of energy, but nowhere near as much as what mitochondria can do by oxidative phosphorylation. Hence, cancers need a lot of glucose. Glutamate can also be broken down, enter this metabolic pathway, and as a consequence, both glutamate and glucose are very, very valuable food sources for cancer cells. And because of this, and because the mitochondria are not working properly, it really changes the microenvironment of cancer cells. It's very different from normal healthy cells. And but it's also cancer's weakness. So that's thing number 1, is you want to remove that food source. Option number 2, that what you need to achieve is you need to restore that oxidative phosphorylation of mitochondria. So you need to bring mitochondria back to normal function. Why is that? It's because when that happens, it literally kills the cells, because kills cancer cells. Oxidative phosphorylation is great in normal cells. Our normal cells need it, they thrive on it, but because cancer cells work on a completely different mechanism, if you reignite that process inside cancer cells, it can literally overwhelm cancer cells and will kill them. Why is that? Because, for example, the membrane, so the wall of mitochondria, can be destabilized. They can release certain molecules into the cell that literally tell the cell, uh-oh, I gotta die. And the cell undergoes programmed cell death called apoptosis. So restoring oxidative phosphorylation process inside cancer cells literally leads to their death. So that's the second goal you want to achieve. And the last one that they mention, what we need to achieve in order to deal with cancer, is to be able to specifically target cancer stem cells. Why is that? Is because stem cells have the ability to divide many times, more so than your regular differentiated cell, and it can differentiate. Stem cells can differentiate or become any type of cell. So if you treat cancer, and let's say you get rid of 99% of it, but within that 1% you leave even like small amount of cancer stem cells, cancer can come back. So your goal is to target cancer stem cells in order to make sure that eradication of this disease is complete. All right, so basically that's the background. Now let's go through the 10 interventions they were talking about and see how they compare in terms of achieving these 3 goals. And I can tell you that half of them achieve all 3, which is fantastic. So we're going to start with natural substances. They refer to them as orthomolecular medicine, which basically means orthomolecular medicine is an alternative medicine approach. And the idea behind this is that you need to have appropriate amount of micronutrients in your body in order to be healthy. And if that appropriate balance is not there, that can lead to disease. This is actually very sensible. This is exactly what is observed. This concept deviates from, say, regular standard medicine is the treatment options. And the reason why is because there is limited amount of data. And the reason why there's limited amount of data on this process is because, well, you can make money off of natural substances. So no one's gonna pump millions of dollars to figure out how it works, because you can make money, right? And that makes sense in a way, because science is extremely expensive to prove things. Anyway, first one of the orthomolecular medicine or micronutrients. The first one, and the one that they spend the most time on, these authors, and clearly it's the one that would seem to me had the biggest impact, is vitamin C. Okay, so vitamin C, they mention the data showing how vitamin C can have anti-cancer properties have been accumulating for over 50 years. Now, vitamin C can actually enter tumor microenvironment. After all, it's just a chemical. And it achieves all 3 of these things. So they mention it targets mitochondria. So they use a variety of terms in this paper that all mean the same thing. Targets mitochondria, restores respiration, is pro-oxidative. All of these mean the same thing, which is basically the mitochondria oxidative phosphorylation pathway is reactivated. As a consequence, mitochondria now produce this electron transport is reactivated, and lots of ATPs are being made. But remember, this automatically can induce cell death. And that's exactly what they're seeing with vitamin C. Again, I'm just paraphrasing what I'm reading in this great article, and they provide references to everything I mentioned. And they say that vitamin C has been shown to really stop proliferation of cancer cells, including cancer cells that are drug resistant, as well as, and this is key, as well as cancer stem cells. So this is great news, right? And that also includes metastasis. So fantastic, it gets that one off the list, right, as well. So now we got two for 3. Now, what's unique to vitamin C against cancer itself, and this was really where my ears perked up, or I should say, where my eyes opened wider when I was reading the content, is that vitamin C can also leads to polarization of macrophages from M2 type to M1. Now, what does that mean? Macrophages are immune cells there, and both M2 and M1 type, and they can switch between those 2 types, are both very important. M1 type is what works for us when these macrophages are fighting, say, cancer or invaders. M2, for example, though, is important for tissue regeneration, right? So both of these types are important and very valuable in our body, but M2 cancers can take advantage of M2 macrophages because it helps to build that cancer environment. So that's a big no-no when it comes to having M2 macrophages in a cancer environment, because it helps cancers. And they are M2 macrophages, as the consequences, are also very key and important for metastasis, so spreading of cancer from one area of the body to another, right? So vitamin C being able to change M2 macrophages back to M1 is super valuable. Another one, though, that where M2 macrophages are also very important is for turbo cancers. I did a series of videos on turbo cancers. Now remember, turbo cancer is not a medical term, and it does not exist as a medical term. It's called hyper-progressive disease, but people prefer turbo cancers, and indeed that's a way better term. So I refer to it as turbo cancers. And the same thing, M2 macrophages are crucial for turbo cancer development. So check out those past videos as well. So big bonus. Now, the last thing is, how do the vitamin C enters our cells? It's via same receptors that captures glucose, and therefore the vitamin C can also directly compete with glucose uptake and therefore reduce glucose availability to cancer cells. That's great. And it also inhibits one of the enzymes or robots that are important for glutamate synthesis or building of glutamate. So that also vitamin C can impede in the availability of both of these very important cancer fuel sources. And the authors, by the way, also refer to them as fermentable fuels. So boom, all three benefits for you for cancer C, for vitamin C. And they also mentioned that vitamin C in high doses is known to be very effective at killing cancer cells and leaves normal cells intact. Now, this is similar phrasing that they're used for many of these molecules that I'll be mentioning, or interventions. And the reason why is, again, because of the fact that you can target that mitochondria inside cancer cells, and that's bad for cancer cells, while it's completely okay for normal, healthy, regular cells. So awesome. All right, next one. We're gonna move to the next one, vitamin D. I did video on vitamin D before, science behind vitamin D, so please check that out. And they mention again that vitamin D has been shown to have anti-cancer properties for almost every single type of cancer that has ever been tested, and achieves all of those three elements as well. So number one, it restores oxidative phosphorylation inside mitochondria, so it restores the mitochondrial function. Number two, it can prevent cancer growth, and it can target those cancer stem cells. So that's great, and metastasis. And it also prevents or limits the fuel source for cancer cells. Again, great. And vitamin D is frequently deficient in cancer patients as well. And they claim you can also help to restore that with higher doses. But for a regular person, it's been shown apparently that if you take your daily regular intake of vitamin D, that actually reduces person's risk of cancer. Awesome. Last one of the natural compounds or micronutrients is zinc. They mentioned that there's something like over 150 papers that have been shown how zinc deficiency is linked to cancer. What's interesting about that is that the greater the deficiency, the lower the survival rate of cancer patients. And zinc, its primary claim to fame is that, again, it restores the proper mitochondria function. All right, next we're going to move to the actual drug molecules. So these are now approved drugs, but these drugs would be used off-label, meaning they would be used, if you were using for cancer treatment, it would be used different than for what these molecules have been approved for. But that's available and allowed in medicine. Doctors are always allowed to use medications off-label if they think that they can be of benefit to cancer patients. And top of the list is ivermectin. I've done a series of videos on ivermectin as well on my Patreon account, so check that out. Now, ivermectin, number one, it leads to autophagy. If you hear autophagy, the first thing that should come to your mind is fasting. And basically, autophagy is like a process that can be activated, which allows for your cells to start eating gunk, basically waste products. It cleans up the system because It targets fuel sources that are not typical, and as a process it's like a cleaning mechanism. Very, very cool. But then ivermectin again achieves all of these three aspects. So targets mitochondria, it removes fermentable fuel source for cancers by, say, inhibiting glycolysis, which is the breakdown of sugar into those pyruvate molecules, or it might prevent glutaminolysis, so breakdown of glutamate into the molecules that you would want for cancer fuel source as well. And it can also target cancer stem cells as well. So, and apparently it's a very safe drug to use for cancer treatment. All right, so that was the first one. Next one is I can never say this, benzimidazoles. I can never say this. There's two of them. Let's see if I can at least remember that. Mebendazole, which is approved drug already, and the other is fenbendazole, which is not approved, but it's extremely close to mebendazole. Mebendazole has been shown to be safe for use against cancer cells. And now these guys, they let's see if I can remember this now. Benzimidazoles, they, I believe, I'm trying to remember, I believe they target cancer stem cells, so that's a big one, and they target access of the food source for cancer. So those are the two big ones, but it has one more that is a little bit different from everything else. It has also been shown to inhibit angiogenesis. Now, what is that? Angiogenesis is basically induction of development of new blood cells. So cancers absolutely want that and need that. They need new blood vessels because as they keep growing and expanding, you still need access to nutrients, and which will be provided to you by obviously blood flow. So you do need new blood vessels surrounding cancer mass, and that's referred to as angiogenesis. So that's another good one. All right, so then the last drug was labeled as DON, and let's see if I can remember the name of that. It was something like 6-diazo-5-oxo-L-norlucine. I might have screwed that up because, again, I have no memory capacity for names. I never had. And that one, I think it does exactly the same things. It can target cancer stem cells, and it can also reduce those fermentable fuel source for cancer cells as well. And in low doses, it is safe. It's non-toxic if it's used in low doses. All right, so those are drugs. Now we're gonna move to those lifestyle changes, and this is really interesting. The first two of those four are diet changes, and this is probably what makes this information so interesting. So the biggest one is fasting. So that's the first one they mentioned, because fasting will achieve all of these three elements we want to achieve. So fasting, first of all, induces autophagy, that process that starts using very scarce fuel sources, right? And therefore it will basically inhibit glucose breakdown and glutamate breakdown. So that's great. It restores mitochondrial function. That's great again. And it can target cancer stem cells. And it has other benefits. It primes normal, healthy, non-cancerous stem cells as well towards their proper function. So, and it also helps the drugs we were mentioning in their effectiveness. So that's fasting. And I've also made a couple of videos related to fasting, so check that out as well. And next one is ketogenic diet. They also refer to as keto metabolism therapy, I think, something like that. Basically what the goal is to induce ketosis, which is basically telling your body to switch from using glucose or sugars as a primary fuel source to fats. That's what ketosis is. And you can achieve this via either diet, B, physical exercise, or C, fasting. And ketogenic diet, again, achieves all of these 3 points that we want. And it, and therefore, again, reactivates mitochondria, targets cancer stem cells and reduces the glucose and glutamate fuel sources for cancer cells. This is why that diet is so powerful, specifically according to these authors, for dealing with with cancer cells. Now, so those are diets. Then the last two things that I'll mention is next intervention is physical activity. And the reason why is because physical activity achieves a couple of things. Again, it targets the mitochondria. So what physical activity can do, it trains your cells to produce more type of like mitochondria type of thing, because you need more fuel, right? So that's perfect. And it will also inhibit glycolysis, so breakdown of that sugar. So therefore you reduce that fuel source for cancer. So fantastic, right? And the last one is, and that one is a little bit odd one, is hyperbaric oxygen therapy. So why is that? Why that one specifically? It's because cancer cells, if they don't use mitochondria for fuel sources, what they need to do is they become hypoxic. They don't need oxygen in order to get their fuel. And as a consequence, the environment becomes hypoxic. So if you now start introducing oxygen, that can be a problem for cancers. And number one, it restores that function of mitochondria, but also you could start introducing reactive oxygen species that will can induce cancer cells to die as well. And also hyperbaric oxygen therapy, it helps as well with drug use as well. All right, so I'm gonna wrap it up here, and I just wanted to basically tell you all these 10 interventions and how each one of them has been supposedly how it can help dealing with cancer. Super fantastic. I will follow this up with another video where I'll tell you exactly how these authors mention what doses should be of all of these should be used, and now that'll be for my Patreon account, and for what type of cancers as well, meaning staging of cancers. And I will also follow up with more extensive video explaining the entire hypothesis as well. Not often do we get new concepts introduced like this, so this is really cool that we got another one. All right, I'll stop right there, and I'll look forward to seeing you in another video. Bye, everyone.